Find the equivalent, also known as total resistance. What they mean by that is in this circuit, they want you to find if you were to just hook up a circuit that was so simple that it only had one battery and one resistor, what would that resistor have to be in order to have the exact same resistance as this big, clunky, crazy thing? Because it turns out there is a magic number that we could put here that would really give you the exact same amount of current as this crazy machine thing. And that's what they're talking about, is calculating the equivalent resistance. It's a very useful thing to do when you're working circuit problems. But there are a couple rules you got to know in order to do it. So these are the two rules you got to know for finding equivalent resistance. If you've got a section that's in series, series means that the resistors come one after the other, sort of like the World Series, so they're all on the same wire. Then in order to combine those, you simply add them up. So to find the total resistance, you just add the numbers. So for example, for this little section in here, we're about to work it, this would be the same as just one 5 ohm resistor. You just add them up. It's very simple if you've got them, just one after the other. But if they're in parallel, which is when you've got two different routes that the traffic can take, then life gets a little bit more complicated. So in parallel, it's just 1 divided by R total equals 1 divided by R1. You just turn them all into upside down fractions and go crazy. And you add it up for however many resistors you got to find the total resistance. So what we're going to do for this problem is just break it down into a bunch of small problems. That's really all the difficult problems in physics ever are, if you ask me, is it's just a bunch of small problems all combined to make one enormous mess. So we're just going to break this thing down one step at a time and keep getting it more and more simple until it's something that we can actually finish on. So for step 1, as I said a moment ago, I'm noticing that these two are in series, so they can easily be combined into one 5 ohm resistor at this location. So rather than having 3 and 2, I'm going to simply put a 5 there and give it a different color since that's something, it's not a real resistor, it's one that we just kind of calculated that would be equivalent to it. So now that we've got that in place, there aren't any 2 resistors that are directly in series anymore, but we do have some that are directly in parallel, this one and that one. So we can actually combine these two using the formula that I had over here to the side. So let's do that. So in the bottom left-hand corner, I just ran the parallel formula for trying to find an equivalent resistance between these two. So you did 1 over R equals 1 over 5 plus 1 over 4. I just convert them to decimals to make life simple. So you've got 1 over R equals 0.45. So in order to actually solve the thing, what you end up doing is 1 divided by 0.45, if you got a little lost there. And that's where I came up with this number, 2.22. So where we did have 2 resistors, we can actually have one equivalent resistor of only 2.22. And it's actually kind of weird. When you have resistors in series, the total resistance is bigger than any of the individual ones. But when they're in parallel, it's a little goofy. You put a 4 and a 5 in parallel, and you end up with an equivalent of 2.2. It shrinks like that. That's actually how it works out, and I wouldn't let that trouble you just yet. There's nothing wrong with that. So let me replace this thing so we can move along with the problem. Okay, now this thing's starting to look pretty manageable. We're at a point where I love this part in a physics problem where everything just kind of came together and you've got one kind of final crack at it and you can just finish it off. All 3 of these resistors are in series, so all we have to do is just add them up. And if you add all 3 of those, you get, let's see, that's 3.7 plus 6. So for the total resistance, you get something like, let's see, 9.7 ohms. Whoops, that's 9.7. So really, if we wanted the same amount of current in our circuit that we had before, we could actually just make a circuit with one stupid resistor with 9.7 ohms, and we'd get the same total current out of that battery. All right, see you on the next one.